parabolas. Yay, they can look like either one of those. If we talk about the standard form of the quadratic, y equals, or f of x equals ax squared plus bx plus c. Just from looking at that equation, how do we tell if it opens down or if it opens up? The A is positive or negative. Positive A opens up like a cup. Negative A opens down like a crown. All right, then we learn special pieces or parts. All right. Look at that. We started finding special pieces. Now the line of symmetry is a vertical line that goes down through the middle of that parabola. It reflects on both sides, your line of symmetry. Anybody remember the formula for the line of symmetry? Negative b over 2a. All right. And it's a vertical line, so it actually ends up being x equals negative b over 2a. And you just pull the b and the a. Now, probably would be better to say opposite of b, because in case you have a negative 3x up there, then you have positive. But we'll get to that itself. Then we talk about the vertex. Vertex. The vertex could also be called the max or the min point. If you have a positive a, your vertex will be a minimum. If you have a negative a, your vertex will be a maximum. The vertex is the tipping point. It's where it goes from down to up. Go from up to down. Now the vertex we can find very easily. We take our line of symmetry and we plug that in for our x value. You actually plug in negative b over 2a, whatever you got, because your line of symmetry runs straight through your vertex. You plug that in, and whatever you get after you plug your line of symmetry in for x, there's your vertex. That's your vertex. We're talking about finding the y-intercept on the coordinate grid. Where does this thing cross your y-intercept? On the coordinate plane, sorry. Anybody remember how to find that one? The easy one. Put 0 in for x. You put 0 in for x, you're basically just going to end up at 0. And then the last thing we talked about were our X-intercepts, our roots, roots, our solutions, or our zeros. All of them the same thing. You guys remember how you found those? It's where it crossed the x-axis. Remember how you found it before you graphed it, though? Up to this point, by factoring. Now, give it 2 weeks, we'll know way more ways of going about doing it. But for right now, if it factors, it'll have nice, pretty X-intercepts. If it doesn't factor, we'll have to go and take different means to do it. Okay? Because you plug in 0, and when you plug in 0, you're going to get 0, 0, all that's left is going to be C. Alright, good. Let's graph a couple. Alright, I don't want to start on number 3. Just right now looking at this quadratic. A, it's a quadratic. It's squared. Anytime the biggest power is 2, I know it's going to be a quadratic. It's going to make a parabola. Just by looking at this thing, it's just going to open up or down. It's going to open up like a cup because my x is positive. It's a positive 1 there. So right now I know it's going to open up like a cup. Let's start in. Let's find my line of symmetry. Negative b over 2a. negative b over 2a. Negative 4 over 2. My line of symmetry is x equals negative 2. So I go to x equals negative 2. Just a nice vertical line. I just like to dot it because it's not really part of the graph or part of the parabola. But there's our reflecting line. Just got to find my vertex. I just plug negative 2 in for x and see what I get out. So I get y equals negative 2 squared plus 4 times negative 2 plus 5. Negative 2 squared is 4 minus 8 plus 5. 4 minus 8, negative 4 plus 5. So at negative 2, 1, I have my vertex. Find my y-intercept. Really easy. Plug in 0. What are you going to get left with? Well, y equals 0 squared plus 4 times 0 plus 5. 0 plus 0 plus 5. Y equals 5. So y-intercept of 5. Now here's the cool thing about that line of symmetry. Everything on both sides reflects. So when I am up 5, how far away am I from that line? I'm 2 away from my line of symmetry. So if I would go 2 away in the other direction, there's going to be a point there. I can reflect that over. Okay? Looking at it, we got our vertex, our y-intercept. What are we missing? Our x-intercepts, solutions, zeros, x-intercept solutions, zeros, roots. Will this factor? Is there any way that I can take this x times x will give me x squared? Since that's a positive and that's a positive, this has to be plus plus. Are there any factors of 5 that'll add up to 4? There's not. So it's not going to factor. And all that really means is that the solutions aren't pretty. In this case, they're imaginary, but we'll get to that. So I have 1, 2, 3 points. I got to have 5. So now I'm just going to use a T-chart. I'm just going to plug in some extra points. I only really need to plug in 1. Now I can plug in easy points. Yeah, I think negative 1 looks about the best we got. So I'll plug in negative 1. I'll get negative 1 squared plus 4 times negative 1 plus 5. Negative 1 squared, 1. 4 times negative 1, negative 4. Plus 5. 1 minus 4, negative 3, plus 5, 2. So at negative 1, 2, I can put another point. Negative 1, 2, get another point. And right here again, the line of symmetry is a time saver. At 2 high, I am 1 away from that line. So on the other side, I can go 1 away, put a dot. And now I have 1, 2, 3, 4, 5 points. I can graph my parabola. And they're not always going to be perfect, but the one thing I do ask, make them curved. Make them curved, make them look like a U. It'll be hard sometimes, but if the graph looks like that, it's going to be more of an absolute value graph. Alright. Another one. Any questions here? Alright, you guys are going to be responsible for this one. this one's tricky. We got a lot of mistakes over these. First of all, right now, is it a quadratic? Why is it a quadratic? Highest power is 2, thank you. Quadratics always make what shape? Parabola. Yes, repetition is good. Is this going to open up like a cup or down like a crown? Down like a crown. All right. So my vertex, that could be a maximum or a minimum point. Yeah, my vertex could be max. Look at all the stuff that we know just by staring at it. Okay. Well, I'll start drafting. Line of symmetry, formula. Negative b over 2a, thank you very much. What's my b value? Ooh, what's my b value? Negative 2. So what's a negative negative 2? Positive 2. Over, what's my a value? My a value, negative 1, so over 2a. So I get a negative negative 2, positive 2, over negative 2. What is my line of symmetry? X equals negative 1. So I go to negative 1. And I put a nice little dotted line, my line of symmetry. Not technically a part of that parabola, but it is very important. Alright. I'm going to find my vertex. How do I find my vertex? I plug in negative 1. So I'll plug in negative 1. And here is a math discipline issue that we're going to have. We have a negative 1 squared minus 2 times negative 1 plus 1. Okay. Do this second. That's a very good question. Thank you. Alright, so we square negative 1. Negative 1 times negative 1. 1, and then we make it negative. We get a negative 1. Negative 2 times negative 1. Positive 2 plus 3. I'm going to end up being at negative 1, 4. So at negative 1, 4, I have my vertex. Let's find my y-intercept. Really easy one. My y-intercept, I plug in 0. 0. What's 0 squared and made negative? 0. 0 times a negative 2. 0 plus 3. I'm at 0, 3. Now I can reflect that across my line of symmetry. I'm 1 away when I'm 3 high, so I'm 1 away when I'm 3 high. I got 3 points. I need 5. Now we can try to factor this. We can factor this. Maybe. Yeah. I would factor out a negative 1. Left of x squared plus 2x minus 3. Will that factor? X times x will give me x squared. Since that's a minus, these signs will be opposite. Does negative 3 have a factor that will subtract to give me positive 2? Yeah. Positive 3, negative 1. Now, if I set both these factors equal to 0, x minus 1 equals 0, x plus 3 equals 0. I'll get x equals 1, x equals negative 2. Well, look. X equals 1. X equals negative 3. That looks work about perfect, doesn't it? So we have roots, we have solutions, we have zeros. Our roots are at 1, 0, negative 3, 0. And now we got 5 pieces. If you look, it still follows the rules of the reflection. That's still 2 away, that's still 2 away. So we now just play connect the dots. And I know you're not perfect, but if you ever miss, put the dot bigger. Remembering this stuff, coming back? Tired of hearing me talk when I get to work? Yeah? Alright.